Hello, everybody, ladies and gentlemen. It's a great pleasure for me to be here today, and I would like to thank Genesis Healthcare for inviting me to Tokyo. This is my first day in Japan, but I hope it's not the last because I like to be here. And I found out that Denmark, which is far away, and Japan are quite similar in many ways. So today I'm going to talk about the Danish National Biobank, which is situated in Copenhagen in Denmark, and I'm going to talk about the past, the present and the future. But before doing this, I will just say a few words about the place where the biobank is situated, and that is Statens Serum Institute, also called SSI. This is, you can say, the Danish National Institute of Health. And our goal is to strengthen health through disease control and research. And just a few key figures from SSI, just to show you which size we are in. We have a turnover of approximately 870 million Danish kroners. We do research for 273 million Danish kroners. We receive fundings, external fundings, for around 110 million Danish kroners. And then we have employed around 630 full-time employees. Statens Serum Institute is under the Danish Ministry of Health. And as you can see here, I have to go back. There. Okay. You see here we have Statens Serum Institute, and then in the institute we have 3 different divisions. We have an infectious disease preparedness division. We have the biobank and biomarkers, from which I'm director. And then we have a research area with different people representing this. So this was just a short overview of Statens Serum Institute. So I will talk about the history of the Danish National Biobank. And what I will tell you about is that SSI, the place where we are placed, we served as a laboratory since the middle of the 19th century. So it's actually quite an old institute. We had millions of samples placed both at the institute but also in other labs and warehouses. And when you were a researcher and you wanted some data, you had to go through very time-consuming journal reviews at hospitals in order to recruit the right patients and find the right clinical information. And also, since the 1990s in Denmark, we started having laboratories in the different regions, and they also collected a lot of samples from patients and stored them at various places. But the problem with all these millions of samples was that they were not registered anywhere, and they were not visible for researchers or obtainable. And this is a big problem. It's like having a huge library and you can't find any of the books you want. So another thing about Denmark I will tell you is that Denmark is a very small country. It's only around 5.8 million inhabitants. But we have something that you got 2 years ago, I just heard. We have what we call a CPR number, a personal identity number. And we have had that since 1963. And we have a large number of registries which covers the whole population. We have a civil registry system. We have a national patient registry where you can see all patients who have been discharged from Danish hospitals. We have family relation databases, medical birth registries, pathology registries. We have registries showing the use of medical products, vaccination registries, and many, many more. And as I told you before, this covers the whole population. So we have unique conditions for population health research, science research. And this is what we wanted to work further on. So we made an initiative to create a Danish national biobank. We made an application in 2008. And what we wanted to do was to get an overview of all the biological samples which were stored on SSI and in Denmark. We wanted to create a national infrastructure which could help researchers all over the country. We wanted to develop state-of-the-art knowledge, both on storage, handling, and delivery of biological samples. We wanted to be able to advise researchers and health authorities on biobank issues, and create a place for researchers where they can store their samples and get biological samples in a cheap and safe way, and according to best practice. And finally, we wanted to develop into a strong partner in international research collaboration. So the dream was, in other words, to create an extraordinary tool for researchers in Denmark and internationally. And we have really been missing this overview in Denmark. So this is a picture of Statens Serum Institute, some of the very old buildings which were used in the military around 1900. Here we wanted to build a national biobank. And here you see the biobank which was constructed in 2011 to 2012. What you see here is that you have a three-floor building. We have all the freezers in the basement here, storage rooms and walk-in freezers. Then we have sample storage here on the first floor. And we have biobank laboratories and offices up here. This biobank was primarily sponsored by the Novo Nordisk Foundation, the Lundbeck Foundation, and the Danish Ministry of Research and Education. Here you see the website from the Danish National Biobank that all of you can easily gain access to. You just have to write this web address here and you will go right into the Danish National Biobank. In this overview here you can see and get some information as how to store samples. You can read about the register, Danish Biobank Register, which I will tell you about in just a minute. And you can read and get information as to what should you do as a researcher if you want to get some of these samples. And then you can see the number of samples. This is actually more than 10 million today. We increase it by around 1 million a year. And in the biobank register for the whole Denmark, we have around 25 million samples at present time. So I will tell you about the concept of the Danish National Biobank. We have 3 different units. The first one is the laboratory and the freezers where we keep all the biobank samples, so the National Biobank in itself. And here you can see an overview of the floor where we keep all the freezers and all the storage facilities. What you can see is that we have both manual and automated freezing facilities. Here, for example, we have a huge robot which can contain up to 6 million samples at minus 80 degrees Celsius. And this is as I said, a robot who makes all the actions here. Also, we have a minus 20 storage automated freezer where we can have 4 million tubes and 3 million Guthrie or PQU cards. Also, we have a large number of nitrogen tanks where we can store samples at minus 196 degrees Celsius. This is very good for samples that should be stored for a long time. And then we have the walk-in freezers. We have 3 walk-in freezers at minus 20 degrees, which can store around 4 million samples. And we have the minus 80 manual storage with 10 million samples. And although this seems a lot, we are almost filled up, so we have to enlarge this biobank within a short while. What we can do in the biobank is that we have what we call a high throughput automated freezing. This means that when customers deliver samples to us, we can receive large number of samples and make them go very fast into the freezing condition, which is very important when you handle biological samples. We have 6 liquid handling robots and 2 DNA extracting robots. So we can handle around 2,000 primary tubes a day and 1,200 DNA extractions. And in the automated storage, we can uptake around 500 tubes per week and 3,000 to 4,000 aliquots per day. And this runs absolutely automatically. So this is a very smooth process. So when a researcher wants to get samples from us, the average project processing time is around 13 days. We can also do high throughput analysis. In Denmark, we very much want the samples to stay in Denmark, and we will very much like the samples to be analyzed in the biobank. Because then you use the same analysis platform, and it's more possible to compare samples and the results afterwards, instead of using different platforms around in Denmark. So we can take, as I said before, around 1,200 samples, which we extract DNA from per day. And then we can make a lot of genetic analysis, such as sequencing, array genotyping, targeted sequencing, mutation analysis, messenger RNA, etc., etc. We can do metabolomics, proteomics, and we do a lot of immunoassays, both within specific illnesses, but also using a lot of different setups. So therefore, we ask researchers if we can do the analysis so that what we give them is data and not samples. A very special thing about our biobank is that we contain all samples from newborn in Denmark. And we have done this since 1982. Every newborn has taken a blood sample from their heel called a Guthrie test or PKU test when they are around 1 day to 2 days old, and it's placed in the biobank. This is a very special material, since this represents no bias if you use these data as a control group in research studies. Often, control groups are biased, meaning that it's special people who want to attend. You get some groups of the society, you don't get other groups from society. Here you have the whole population, so it's not biased in any case. So this is very popular material for research studies. The next part is the register, which I will tell you about, the Danish Biobank Register. This is a register that you can also see if you go into the biobank website. What you will find if you go into the biobank website is, this is in English, and what you will see is that you can search for samples. It's open to all researchers. And you can search for samples in specific illnesses. For example, if you want to study breast cancer, you can look for samples from patients before, during, or after diagnosis. We use US ICD-8 and ICD-10 disease codes, and you can make big searches and get results within a few minutes. Of course, these data are anonymized. But this makes it possible for the researchers to make the right applications. So you can apply for fundings or for ethical approval, etc., because you know exactly what kind of samples you are going to use. So this makes the research process much faster and much more easy for the researchers. What is special about the Biobank register is that it links together all the registries I told you about before and the samples via the CPR number. This means that you can take some of the registers and maybe you will look into a specific area, and then you can search in the register to find out where are all the samples you want. Are they situated in the Danish National Biobank or some of the other biobanks? And then you can apply for the samples. So it bridges between samples and registries. I'll tell you some examples, but what we say in Denmark is that we can follow the population from birth to cradle. And this is shown in this figure here. When someone is born here, you can, via the registries, look at birth circumstances or family circumstances. Then during life, the person may have taken some samples, blood samples, other kind of samples, and you can take these samples and combine them with information regarding new family circumstances, vaccinations, or medications. Then probably a person is getting ill. You have a sample here, and you could look at diagnosis and medication, treatment, and when the person dies, you can look at the whole lifespan or different kind of things during life. So all of this is combined via the CPR number. So we have in today information about 5.4 million Danes. So we can follow diseases through many generations. And this is very, very important for research. One example I can give of a study which has used this combination of data and registries is a study that took place a few years ago. It was a study looking into a disease called pyloric stenosis. This is an illness you see in newborns. You can see a newborn here, and here you can see a normal stomach and intestine here. What happens when you have pyloric stenosis is that you have a large enlargement of a muscle situated here, and this means that the milk cannot pass through the intestine down into the system. And this is actually the reason for most operations in childhood in Denmark. And in the old days, children would die for this disease. Today, you can easily remove this muscle and the child will be well. But they went into the registries and said, how is it with this disease? Is it genetic? Can we explain the illness by genes? And what they found is, if you look at the relative risk here for pyloric stenosis, and you look at different kind of relations. For example, if you are a monozygotic twin, if one twin has pyloric stenosis, then you are 200 times more prone to pyloric stenosis as a monozygotic twin. And if you're a sibling, you have 20 times as high risk for pyloric stenosis. So they found that there was indeed a family linkage, and they followed Danes up to 4th generation and found this information. Then they went into the biobank, and they found blood samples on 1,000 cases of pyloric stenosis and around 2,400 controls. And then in the biobank, we did DNA extraction, and we looked at some different genes, and we made some different genetic analysis. And here we were able to identify 4 genes which were important for the disease development. And I have to say that this data was published in Nature Genetics in 2013. What they found, I can show you on this figure, was that, first of all, that chromosome 11 was the chromosome which were responsible for this genetic illness. And previously they found that this gene was also connected with low cholesterol level in blood samples. So they found, if you look here you have the risk, or the odds ratio on the y-axis, and on the x-axis you have the quantile of cholesterol. Meaning that if you have a high cholesterol level in your blood sample, you have a low risk of pyloric stenosis. Whereas if you have a low concentration of cholesterol, you have a high risk of pyloric stenosis. So this was important because bottle-fed children, they were found to have 5 times as high risk of pyloric stenosis and as children which were not bottle-fed. And this is because bottle-fed bottled milk has lower cholesterol level than normal milk from the mother. So everything made sense when we went into this study. And this has also been published in JAMA. So these studies can be made because we can link the epidemiological data, the registries, with the biobank. I'll just show you what kind of samples we have in the biobank. And what you can see here is that the red bars are number of samples, and the yellow bars are number of individuals. So if you, for example, look at, let's take cancer or neoplasma, we have samples from around almost 700,000 samples from more than 300,000 individuals. And here we have listed all the different disease categories. So there are very many samples into all categories. And one of those who are also important here is a control group. Control group are always groups missing. As I told you before, it's always biased to some extent. In our biobank, we have almost 1 million controls. This means there are no data that these persons has been sick. They may have given a blood sample because they are blood donors, or etc. So this is a very important category. What we have also done on the website, which you can also see if you go into the website, is that we have categorized the different groups of illnesses, meaning that if you, for example, look at Alzheimer's disease, and you want to make a study on Alzheimer's disease, you can go in and see here that you have spinal fluid from 800 patients. And among these, 200 before diagnosis, 200 at diagnosis, and 400 after diagnosis. And you also have serum from more than 2,000 patients. Among these, 1,200 before diagnosis, 400 at diagnosis, and 600 after diagnosis. And this you can see from the various group of diagnosis. And this makes it easy for the researchers to see what is in the system and what can they use. So this is what I showed you before. The new thing is that we are working on linking laboratory results to this registry also. And if you look at the laboratory we have in Denmark, then first of all, we have the data from SSI up here. Since we were a laboratory for many years, we have around 13 million test results from 1993 to 2000, and 55 million test results from 2000 till now. Then we have something called the COPLAC database. And this is blood samples and other pulmonary function and EEG tests from patients from Danish practitioners from the period 2000 to 2015. And here we have 176 million results. And finally, we have the nationwide laboratory database, which is covering 89 laboratories and have around 1 billion results. And you can see, if you're going to look at some of these electrolytes here, for example, albumin, you can go into the database and see that we have more than 28 million results on this. And then you can link it to biosamples and registry, etc. So what are the future plans? Well, first of all, we want to establish a data bank. Not only what I showed here about laboratory results, but we are also working on establishing a data bank, meaning that every time our biobank samples have been part of a study, we will get the results back and put them into a data bank. This means that when new researchers are starting on a study, they can see what has already been done. Can we build on existing results to create new results? And this will speed up the research process very much, because often you do things which has already been done because you don't know what has been done. So this is something we are working on at the moment. Also, we are planning to establish a microbiological biobank and a register, since we at Statens Serum Institute has around 1 million microbiologic samples since the middle of 1900. So here again, we have something which is very important when we talk about antibiotic resistance and infectious diseases, etc. We are working on a new version. If you go into the web site, as I showed you, today you have to do it on a computer, but very soon you can do it on tablets, smartphones, etc. And also we are working on having new freezing facilities. Today, when you deliver a sample, it has to come into a small vial and into the biobank, the robot. What we will work on is now to create some semi-automated system, so that when a researcher has, for example, 2 boxes of samples, you don't have to register every sample, but you can just put the box in and keep it in the freezer. This makes the delivery process much easier. Then we are working on increased outreach activity, just like I'm doing today, showing you that we have a biobank in Denmark, but also to show researchers in Denmark and generally internationally that we have a very important biobank. And for that we have hired a science journalist, and we communicate more and more through the social medias. And finally, we are working on accreditation of our laboratory and the biobank according to a new standard. So we will be the first biobank in the world who has this accreditation, and we expect this to happen in the beginning of 2020. So this was all for me, and I hope you enjoyed the presentation. I cannot invite you all to see the biobank, but right now you had at least had a little look into it. So thank you very much.